Welcome, everyone. My name is Helder Mendes. I'm the project manager for the iConspicuity from Research and Innovation area here in EASA. So this project is finishing now. It was a long run until today, and I have to thank everybody, especially here, the colleagues on the room, Vlado, Helge, Olaf, and Max, that they were always together. And before them, it was my counterpart project manager, Uli, that was also with the same standards, providing excellent work. And this today, it's the end of this stage. So we'll record this session. If there is anything from you that have some objections of this recording, please say so. And also some pictures will be taken during the session. Again, if there are something from someone against it, please say so. The same for people online, especially for the recording part. Welcome everyone online also, because this is a big session. It was dimensioned first for a smaller amount of people, but then it grew, and now we have a big group there online attending. So that's it for my part, except the catering. Today it's an unfortunate day. We had to take care of the catering ourselves. Just coffee, water, you are welcome to take it. And I handle to Vlad, which is the technical lead here in EASA. He will provide some technical details of this project and also present the EASA team that was with him working here. Thank you very much.
Thank you, Helder. I think it's we continue with the presentation of the team. Yeah. So I hand over to Horvat to go through the initial slides.
Exactly. Yeah. So thank you very much. Maybe just go one back to the agenda. So what we have today on the agenda is, first of all, we start with a short introduction of the team who was working on the project, and then we will give some background information regarding, in general, the Horizon Europe project, and also Vlado then will talk about the introduction of interoperability. And then we will start with Helge, who will then present the final technical results of this project. And of course, we will then also discuss the next steps which should be taken. And we'll then have a dedicated Q&A session. But more on that, if you have any questions, we'll come back to that later. We'll use Slido for this one, but will be introduced in a few minutes. So, who was working on this? First of all, maybe let's start with the EASA colleagues. Maybe you want to introduce yourself quickly.
Yeah, Helder introduced himself already.
So my background is avionics engineer. I started as an avionics engineer. Then I specialized in flight data analysis. So I always worked in aviation, first in the operator in Portuguese operator, and then I switched 6 years ago to EASA. So this is my path on aviation. Yeah.
Well, thank you. You see the name Vladimir Foltin. I'm in EASA for over 13 years now. Initially, when I was at ATM, last 4 or 5 years, I'm deeply involved in GA Golf certification, where I'm acting as a PCM, but also having the role of ATM experts there. But my primary reason why I'm here is GA. I'm a project manager for GA Flight Path 2030 Plus, which is our GA all-encompassing project.
I think
horizontal project for EASA for GA matters, where we try to harmonize the measures and regulations for GA in a coherent way. And iConspicuity ADSL, I'm acting as a focal point there. And iConspicuity and ADSL is one of the major pillars of our work in GA, and therefore this project is very important. Over to you, Ola.
Yes, thank you, Vlado. So a short introduction of the project team. So we'll start with myself. So I'm Olaf Müller, working for Harvard Consulting Company in the transportation sector, working on aviation projects and also rail and logistics projects. And then Helge, who's the technical lead project, and then also Max, who supported on this project. And the colleagues from Dornick who are also here in the room, Alexander and also Ralph. And then there are some colleagues which are not in the room, like Jan Erik, who also supported on the project, and also, for example, Tom Högge from Deutsche Telekom, who also supported, but could unfortunately not join here. So let's maybe go to the next slide. So for any questions during the presentation, we set up a Slido, so you can all now go to slido.com and then enter this code here, or use the QR code. You can find here, you can scan it with your mobile phone, and then you can directly go to slido.com. And there, if you have any questions, of course, you can always post them online, and then we have the chance to go through all the questions systematically. So, and we'll answer, of course, always the questions in between or in the end in the dedicated Q&A session. Yeah? And of course, there will be some discussion at some point. Then, of course, you can also unmute yourself, yeah, and we have a small discussion and discuss the points you might have. Yeah. But maybe check if the Slido is all working for you.
Yes. At least the QR code is.
It's working?
It's fine.
Okay, perfect.
I'll put it in the chat.
Exactly, yeah, that's maybe a good idea. So if you want to join later on Slido,
Yeah.
just use the link Vlado is now posting in the chat.
And I will put a link there as well.
Okay, perfect. So then let's start with the background of the project and the introduction.
Okay.
Vlado.
Yes, yeah. Background, next slide, please.
Yeah.
Yes. So I would like to remind ourselves what's the main reason why we are here in this room today. And there has been some time since we analyzed the collision problem in Europe. So back in 2018, we've taken endeavor to go through analysis of why there are collisions happening in Europe. At that time, we did initial safety analysis based on fatalities, and what we noticed there that we have a stable number of collisions over the 11-year period, but growing number of fatalities, and that being topped up by all the other issues like drones starting to operate those days, and more and more demand for the airspace from other sectors. So looking at the data, we came to the understanding that we have all these collisions happening in to traffic that is not subject to air traffic control. So focus was on uncontrolled aircraft, and vast majority of all collisions, fatal collisions, happened and involved smaller aircraft, not large aircraft. So that steered our efforts those days, and that was a starting point we had to analyze. So in the subsequent analysis, next slide please, we identified 4 problem areas. I will not go in detail through them. The drones operation was the new emerging problem. The 3 remaining ones were pretty established. What we also learned that the airspace makes a lot of impact on how traffic behaves in the air, especially uncontrolled traffic, which was our concern. And we wanted to address these problems, all these problems, probably the best way, so that it could be acceptable and affordable to the communities. Next one, please. So we quickly understood that conspicuousness, which stands for being visible, being detectable in the air, and in combination of airspace, should be in the heart of our actions. But ideally, and that's the next picture, ideally, we should combine the two. So if we can be conspicuous in all airspace and get information we need to have for safe flight, in flight, that would be the right direction of actions, how to tackle the problem of collisions. And this is where iConspicuity started. Of course, understanding the emerging drone operations and needs from both business and state operators, we realized that we cannot drift away from use-based development. And at that time, we also said clearly that we will, whatever we will do to manage conspicuousness and collision avoidance in any airspace remains consistent with our use-based development. So effectively, we are using use-based regulation as our only regulatory reference. Next one. So, what the iConspicuity stands for, brief explanation of that is that it's about connected aircraft for better, and this is a key word here, situational awareness. So we are aiming with this to improve situational awareness, not only for pilots, but also for those on the ground. We are not talking about surveillance, we're not talking about detect and avoid, we are talking about improved situational awareness about surrounding traffic, airspace, hazards like weather and others, to be able to for pilots to be able to execute flight better, and for those on the ground to be able to execute their functions and those better. The I in the beginning can be also interpreted as inverted acclamation mark, and conspicuity is a baseline of all of this. It's a basic foundation brick in all of this, because without being conspicuous, all of these other things would be unachievable. Next one, please. At that time, we've set the comprehensive action plan. What you see on the slide is all the actions which are reflected in our European Plan for Aviation Safety on the left side. You note on the top left there is this task we are actually finalizing in this event, Research Task 0031. There was some delay due to pandemics and funds unavailability, but we are well into this program at this point in time, and we will be sharing with you the next steps, which will be building, completing this program, and also building on what you see on the screen. As you can see, we are using existing regulatory vehicles or tasks which are underneath. We are using CS standard changes. We are using use space as a solely regulatory reference for mandate for conspicuity, and we have also rulemaking task 519 about CSA/CNS, and there is also ACAS included in there. So this is what we are doing, and this concrete research was important, as you see, enabler for many other tasks, as you see on the arrows there. Next one. Then, when we made the analysis, made the plan, this regulatory requirement came in. This is the SERA, famous SERA 6005 Charlie. I don't read it, you all know it. And this is what we are trying to achieve along with this task as well. We have developed proposal and solutions for how to be conspicuous in new space, but there was a need to further consolidate and converge, and therefore this research was essential. In the development for use space, we came up fairly quickly with the need of simpler language for devices to cooperate to achieve interoperability while keeping the devices as affordable as possible for end users. Ideally, also allowing older devices to be updated with the software change. So the key word of our new ADSL, Automatic Dependent Surveillance Lite language, was affordability, interoperability, simple sensor, only GNSS, while paving the way for more privacy and security of the transmission. So there are some features in this protocol that set the possibility for people to address these dimensions. This is now in place, and this work was all considered in this project we are finalizing today. Next one, please. Famous 3 ways of transmissions in use space, how people could be conspicuous. I'm not going to go into many details. What is innovative here, we have started as a European regulator to look at the non-licensed, non-aviation, non-certified, and non-protected spectrum, however regulated spectrum, to have basic level of possibility to intervene. And we were looking at existing resources, and these were SRDA60 and mobile telecommunication services. The next one. But there is also other dimension, and this is for use space, and this somehow requires certain infrastructure, but we need to address the problem of collision also outside of use space, and that was the major challenge of this project. Next one. Yeah, that's it. Okay. Over to Olaf and okay.
It's for me. Okay. Thank you very much, Helder. Thank you very much, Laro and Olaf and Max, for the introduction. Thank you very much for the audience for joining us today. And thank you to all the pilots, organizations, research institutes, developers, manufacturers, and of course, all the EASA staff for supporting us in our project here. Today, we will present your work as well. So today we will take an overview about the course of the results and our project, and some statements will overlap in the sequence of the slides. That's because we integrated all the results into the previous project steps, and so you always see the current status of the respective topic. You can find more details on the project website. I guess Olaf already published it in the chat, and all documents from the project are published there. So why are we sitting here? Laro told us already some things. So there are 2 reasons. One reason is the high number of collisions, mid-air collisions in the general aviation. And I quoted here something from a recommendation from a BAA accident analysis from 2020. And it requests us to complete the interoperability of electronic conspicuity systems to prevent those accidents. And the second reason is the Sierra 605 Charlie, you already talked about it, that manned aircraft have to be electronically conspicuous in the use space if they are not under control of the NSP. And there are 4 means of the conspicuity in the use space, and Lara was already talking about it. It's a certified ADSP system, UAT, and the 2 ADSL systems. UAT is only authorized if it's authorized in all of the member states. So the pictures that you see here are symbolic pictures, and you might have seen them in different versions in different projects already. They show the current situation and our target picture. And on the left-hand side, you see the current situation, and not everyone is able to see everyone electronically. seeing the void is still the basis of the general aviation, and the detection rate of seeing the void is still below 60%. It's between 40 and 60% of the traffic. Currently, the seeing the void is supported by some electronic conspicuity systems, but they are mostly not interoperable. So what we would like to achieve, you see on the right side, is the situational awareness for everyone in any airspace and on the ground as well. And we would like to realize that without a mandate, and the use of iConspicuity systems should be encouraged comprehensively. And what we need for that is standardized data communication by interoperable systems. And we have a major goal. We want to use as much as possible of the existing equipment which is already in the air. And we would like to open up new capabilities to display traffic, for example, for model flying. So here you can see our project approach, the project's course. And we began at the beginning with collecting all the input systems and technologies like FLAM, ADS-B, radar, and so on. And we reviewed these systems under different aspects like sustainability, capability for network, costs, user acceptance, and so on. And to support this review, we set up a survey for general aviation pilots, and we asked them for which systems they are using and what are their experiences about it. We got about 2,100 participants in this general aviation survey. Then we started with these inputs, our workshop number 1. And we derived the interoperability requirements and set up the target system combination, which will be explored further later on. Then in between the 2 workshops, we set up a lot of technical meetings to find out the mobile network usage issues and different transmission paths, the frequency congestions, and so on. And in workshop number 2, we went into the workshop with all these technical meeting inputs and derived the interoperability levels. And we defined 3 major levels that was technical, operational, and user side. Latest, we made 3 case studies for the 3 transmission paths and 1 additional case studies for the benefit for search and rescue, flight information service, and training due to the ability of these large data sets of iConspicuity data. And today we will present you the overview over the results of our project and the outcome. And throughout the entire project, we have been constantly in contact with the manufacturers, experts, and we have incorporated their opinions into our results. So this was the timeline of our project. We began a little bit late in December 22, and we started the survey in April, and it went up to 5 weeks into the May of 23. And then we started with the workshop number 1 in July. It was planned before, I think, in March. Because of the pandemic and all other things that happened, we had a little bit late start in that. We had a lot of technical meetings between July and November, and started the workshop number 2 in the beginning of November. And we ended up with the case studies in April this year, and now is the final dissemination event, and the final report will follow up in the mid of July. So what did we do in the general survey? It was set up about 5 weeks between April and May of 23. And the focus was to find out what electronic conspicuity systems are used in the air and what are the user experience with those systems. The survey was anonymous and it was distributed widely on events and on social media. And even if we did ask there for individual systems, the project never evaluated individual systems, but we did rather do the technologies and transmission paths that we evaluated there. Little recap on the survey results. It was a very impressive number of participants, which we did not expect. It was over 2,133. And on this slide, you can see a little bit the composition of the participants and the used systems. And the first important task came out there very clear from the survey. It was information and communication. We have a big lack of information from pilots, clubs, rentals, they are not very well informed. And what we learned there was that 22% of the users are not using any system, which is an alarming high number. And there were also some interesting facts. The pilots want to have this interoperability of their systems, and they would accept even higher costs, even higher investments for the right equipment. We got about 2,000 comments in this survey about the systems and the usage, and we got a very good overview about the current situation. You can look up the detailed survey report also on the website of our project website. So a little recap from workshop number 1. We began with a survey. We discussed it with all of the workshop participants. And after that, we presented some position papers from the ADAC Air Rescue, the European Hang Gliding and Paragliding Union, the European Model Flying Union, and a strategy paper of the German Aero Club, Air Traffic Controllers Union, and Cockpit Association, and AUPA. The aim was to find out the different needs of the pilots. Then we did a little research on accident and incidents, and what we can say is there are collisions between all types of aircraft. There are no exceptions, and not every incident is reported. And we took a look on further initiatives, the Safe Sky project in Aachen, which accompanied us over the entire project time, some UAT projects, as well as ground-based apps and digital radio for the workshop number 1. And we reviewed additional technologies, for example, like the demand-controlled night markings of wind turbines, flashlights coupled with alarm, and so on. Camera-related systems as well, and remote ID also. And which follows up was the interoperability criteria, and at least they led to a target system combination, which I will show you in the next. This is our target system combination, which consists out of 6 technologies and systems. That is the certified ADS-B system, the 2 ADSL systems, the FLAM system on edge technology, the mobile apps, and the ground-based apps. And of course, we know there are a lot of more systems in the air, like radar, Mode S, you see them on the right side. But we decided to take a scope of the project onto these 6 systems. And the other systems on the right side are still under investigation, but they are not focused. They were not focus of this project. Then we prepared the workshop number 2. In between, there was a lot of technical meetings. The topic of these meetings were the mobile network issues, like range, speed, neighbor cell switching, obscuration, and so on, and provider contracts as well. And the 1090 load, ADS-B additional load if you switch Mode S to ADS-B, disturbances, and so on. Then we did a clustering of the users by the main transmission methods, and we decided to use the 1090, the SAD, and the mobile sections. We considered some more further developments, so ground-based apps, which I come later to, nascent technologies like satellite-based internet and communication, the Mode M system, which comes up right now as an alternative positioning system to GNSS. And with all those findings, we collected the main needs and constraints for the interoperability in the target system. And in summary, we developed a future view of iConspicuity, which I show you here. There are 3 areas, which is the certified environment on the left upper corner, and it's the uncertified environment on the right side, and that's the ground infrastructure that we need on the bottom. The aim for the certified systems is to upgrade the Mode S transponders, which are upgradable to ADS-B. It's for better conspicuity, and it's integrated the position info. So that can be eventually supplemented by low power devices combined with Mode S transponders, and that works for all levels and speeds of aircraft. In the uncertified environment, that includes the ADSL systems, FLAM systems, and other multi-link systems. Like, for example, an ADSL for SRT860 together with 1090 in. And optional with the mobile network connection, it will be a good multi-link system. That's good for low and mid-level flying and medium to fast aircraft. And also, there's an uprising number of mobile applications. They are for low-level and slow-flying aircrafts, and they are connected to the mobile network. The ground network consists out of the ANSP, of course. They're collecting via secondary radar and the ADSB receptions, and the 1090 networks like ADSB Exchange. There's also the networks from SRT860 and the mobile network as well. And all in common, they need a connected traffic network. And the ground-based apps are connected to this mobile network and then via the traffic network as well. Now I'd like to shortly summarize the parts of the target system that we found out, the 6 parts, and include the findings of the workshop, technical meetings, and case studies. The first one is the certified system, the ADSB system. And to take a closer look here, what we would like to achieve is that we switch up the Mode S transponders that are upgradable to ADSB. The Mode S and ADSB are very well known as international standards, and the properties are very well known as well. And what we have to consider is that the TCAS systems are working on Mode S technology on 1090, and they must not be disturbed in any way. So we did a survey with the feedback from major manufacturers of transponders in Europe, and at least 77% of all existing transponders can be upgraded to ADSB by simple adding a GNSS source. It is compliant to 0605 Charlie because it can be in accordance to the CS standard. So mostly you will get an ADSB out system with source integrity level of 0. The source integrity level is filtered out by the most of 0 is filtered out by the most ANSPs like the Deutsche Flugsicherung. What could be a solution for the upgrade of systems that are not upgradable from Mode S to ADSB? It could be supplemented by low power ADSB, and we need an exception in the EASA member states for that because it does not meet the ETSO standards. What we did at Dronic was very interesting. We had a drone with a Ping 20SI test in Frankfurt Airport and let it fly with a SIL level of 1. And the tower in Frankfurt could see us. And then we tried to register this transponder, which is a low power unit, at the Federal Network Agency, the Bundesnetzagentur, and they released it. And they already said it's EASA approved. Pretty interesting. So we come to the both ADSL system in our target system, and what ADSL is, I think Lado told a lot about it. It's an open protocol without fees. It was derived from ADSB and it's simplified. It was originally planned as a surveillance protocol from the air to the ground. And both variants of it, like the SRT860 system and the mobile system, are means of conspicuity, electronic conspicuity in 0605 Charlie. The specification number 2 for ADSL for SRT, ADSL for SRT860 is published soon, and the specification for mobile has to be started now. One thing is integrated now, it's the remote ID, direct remote ID for drones is now integrated in this specification number 2 in the protocol. So we come to the SRT and FLAM systems, especially FLAM here. They are on the market for a very long time now, and they're pretty mature systems. And they are already available in combination with other transmission paths, for example, 1090. And they are coming up the first systems which will integrate ADSA already orderable by FLAM on their website. There's one issue about the frequencies. The World Radio Telecommunication Conference 23 discussed the usage of adjacent frequencies of the SRD spectrum. for mobile and satellite communication, but I talked to the manufacturers and the problem is already solved by the FLAM technology. So the saturation of the receivers is not a problem anymore. And one point every user can change in using these systems is the point with a small range. It's mostly because of unfavorable antennas and antenna positions. And external use of external antennas will extend the range very much of these systems. So a closer look to the mobile apps. This is clearly the cheapest solution for iConspicuity and exists in numerous variants. And they're mostly connectable to navigation apps to display traffic on the navigation apps as well. And they have the ability to migrate different data sources to be displayed on your app then. The limitation of those systems is linked to the communication path, the mobile network. It's the issues are altitudes, speeds and stability of the connection, obscuration of the aircraft, and the contracts with the network providers. We discussed those things very extensively in the technical meetings, and currently we see the mobile network usable as a complementary system when other systems of transmission ways fail. So we come to the ground-based apps. What's that? I don't know if anybody knows about the ground-based apps. They are just upcoming. And I would like to show you an example. That's the Fly DMFV app, which we programmed at Tronic Company. And it's informing the traffic users, the airspace users about model flying. The information about a model flight will be displayed on your traffic systems here, the Tronic UTM. It's on the upper right corner. Unfortunately, it's very, very dark picture. And if a model pilot activates a flying sight in his club, or he is flying on a green field, the traffic information is displayed as a circle with a certain height and diameter. And as a manned aircraft, you can avoid this area then. This solution was made for Germany, but we will expand it now to European associations as well. It's a little bit difficult because of the different regulations in the States. As well, we are discussing about the usage of the system for hang gliding and paragliding as well. So you can see their starting sites and landing sites. So after this information about the target system and after all the workshops and technical meetings, we developed the case studies and we decided to do it according to the transmission path, to the main transmission path which we identified. And as you see, the resulting tasks are mostly already presented in the closer look of the target system parts before. The conclusion is in the 1090 paths, we should switch as much as possible users from mode S to ADS-B, because the position information is integrated then, and just a GNSS source. So this is the certified part, certified solution. In the SRD 860 part, we should enable the ADSL protocol and set up ground stations to pick up the informations and communicate with the SRD systems. And we need a regarding network for that. That's the uncertified solution. And also there, it's the mobile part. And we have to reach out there for a stable transmission and reception as well. And also set up the ADSL protocol and the ground network infrastructure as well, the traffic information network. This is the portable solution. And we also did an additional case study for the benefits for flight information service, training, search and rescue, and safety analysis. And we'll give you an overview over this additional case study. What we found there is that search and rescue becomes very much faster and more efficient if they have access to real-time traffic data. And safety analysis is much easier and accurate with the access to large data sets of electronic conspicuity data. But therefore, we need the storage of this data. And we can integrate safety mechanisms from commercial aviation in the general aviation with all of these parts. The flight information service will also clearly benefit from the integration of iConspicuity because they see more participants in the air. Just for example, the flight information service sees Mode S transponders, but the pilot in the glider doesn't see it. And the pilot in the glider sees FLAM systems, but the flight information service doesn't, so they can benefit from it. There's also a lot of benefits for ground and additional users as well for integrating iConspicuity. So what developments did we see in the last month about iConspicuity? We had the so-called ADSL coalition, so that manufacturers developed new and upgraded systems to integrate ADSL. Here you see some examples of the manufacturers, and it's not complete. Even this is not intended to be a recommendation. So you see here the ground reception solutions with integrated ADSL for building up ground networks, as well as the update for the FLAM software with ADSL. You can download it on the website then. And there are also multi-link devices without a very great installation effort. You can just put it onto your glare shield and it works. And we have new traffic receivers like those two, which are connected with Bluetooth and Wi-Fi and mobile connection. We have new transponders which have integrated systems like the TAPS function, it's traffic awareness beacon system function, so that they not respond to they don't answer to every SSR request. And we also have here some drone solutions for ADSL as well, and for the hang gliders as well. And another very important development is the iConspicuity declaration. I think that's a point that Lara will talk about later. And no pilot should be punished for inadvertent violations because he is conspicuous. That's a very important part to get the people to iConspicuity. So now we come to the action plan, which is clearly not complete, but it should give you an overview about the main steps that have to be done. What is one of the main ones is we have to keep up and expand the communication about iConspicuity. And we also have to inform the pilots about use space and its tasks, because most pilots don't know very much about it. And they are pretty scared about the use space. And we have to listen to all user groups. The hang glider pilot is as important as the powered plane flyer. The ADSL specifications must be done in time, and the ADSL for mobile has to be started very soon. We have to do some researches in terms of frequency load on 1090, for example, the traffic networks and the storage of traffic data. And in this context, we need a minimum standard for conspicuity data and the transfer ways as well. Then we have to clarify the aerial usage of mobile network European-wide, especially the provider contracts. We have to build up a just culture in form of the iConspicuity declaration document before. At least we need a good human-machine interface in the devices, because we must achieve a positive safety gain. If the user and the pilot is overwhelmed and distracted from his pilot's duty with the operation of those systems, then we have a safety loss. And at least we need support programs from all sides, from manufacturers, government, and it's for our own safety. So welcome to my last slide. That's the final conclusion. What we have to say is that the basis of iConspicuity in the General Aviation will always be the combination of uncertified and certified systems. And the interoperability, which we were talking about, is made possible by the multi-link of the different transmission paths with consistent language like ADSL, and we need traffic networks on the ground. We have a lot of tasks to accomplish, like the ADSL specification, test environments that we need to build up, the mobile network issues and the groundwork network planning. And at least we have to keep up the conversation and the information of the pilots. I would like to say thank you to all of you, And we set something in motion here and mobilized pilots from all sectors and got them involved in this project, and that's for our own safety. Thank you very much.
Thank you very much. What's next?
So now we have next
Okay.
steps.
Okay, so let's continue. Okay, so now I would like to outline you what are the already decided or planned actions as a follow-up of this 1.5 year long research on iConspicuity interoperability. It was very interesting times and loads of useful discussions from all directions. Many of issues were raised and learned, and most, if not all, is reflected in the final deliverables. First of all, I would like to confirm that this is and will remain high priority for EASA and our partners. One of the things we decided already internally as a proposal, we will be proposing to our stakeholders to create a specific activity group for this initiative that will be established under our industry stakeholder structure, stakeholder advisory body, SAB. We have a dedicated General Aviation steering group underneath, and that group is, according to our new rules of procedures of SAB, that group can create activity groups that will encompass all relevant stakeholders to steer and work together on this activity. So this summer we will be formally establishing this group, and we will invite active stakeholders into the group, into the activity group, to further steer ADSL iConspicuity and results, also to translate results of this workshop into actionable items. Don't worry if you won't be directly involved in the activity group. This group will create a list of interested parties. So those who will be interested to be regularly updated or regularly contribute to the group, for example, by correspondence, providing comments to the outcomes, they will be involved. And what is important here is that in General Aviation, in EASA, we never split or exceptionally split national aviation authorities from industry. So our GA meetings are always co-organized together between the authorities and industry and associations. The primary reason is lack of resources or limited resources on all sides. But more importantly, this allows for open discussions and tackling the problems from all perspectives at one go. So we do not have a separate discussion on one topic between authorities and then between association and forming two different opinions, but rather we have hopefully one opinion of the group, both NAAs, EASA, all NAAs, EASA, and stakeholders. So this is short-term action. We will be creating this group. We will be announcing it publicly on our GA community website as well. And all those who have been in contact with EASA throughout those 4 years, either through the project or through the development of acceptable means of compliance to SERA 605 Charlie, will be automatically subscribed. We will also invite other stakeholders who wanted to be in connection with this activity group to inform us through our stakeholder bodies. So that's iConspicuity activity group, which will steer the work. The next one is, I think it's about ADSL. So I have pleasure to announce that key industry involved in SRD-860 spectrum was over the last few months we're working on the improvement of ADSL for SRD-860 specification. Now the issue number 2 draft is nearly ready for consultation, focused consultation. There is a typo, we will correct it. It will contain 3 main additions. First area, there were some typo errors or mistakes, small mistakes, or there was in some areas need for further clarification to the issue 1. So we have tried together to improve this area. So issue number 1, which is compliance with SERA 6005 Charlie, is improved or should be improved, and we will seek further improvements through this additional review process, external review process. This is the regulated part. We are not changing anything there, just improving, clarifying. So this doesn't mean that there is a regulatory part being changed. Then we are introducing possibility for drone operators to transmit remote identification using SRD-860 spectrum. So there will be EASA for drones, remote ID for drones. I need to emphasize here that this is not network remote ID, but this is solely and only in support of SORA operations outside of use space. Currently, there are 2 technologies, standardized technologies, how to transmit remote identification of drones, Bluetooth and Wi-Fi. In ADSL, we have added in the draft exact the same transmissions, but different spectrum. So they will be able to use SRD-860 spectrum. So this will unlock the opportunity for drones to be visible to drone operators using ADSL. But not only that, it will also open the opportunity for drones transmitting ADSL to be visible to General Aviation. It doesn't mean that we expect General Aviation to be avoiding drones, because to spot them by plain sight, it's nearly impossible. But it's a safety barrier. If people know the drones are operated underneath, they take more cautious actions. And this is what we see by geopilots. So this should add to the safety, especially outside use space. And we are also introducing, thanks to a numerous call by our stakeholders about UAT capabilities. Some countries allow UAT transmissions, some not. So we wanted to allow all European pilots to benefit from this clever technology. So what we have decided and tried to incorporate is to use UAT-like retransmissions instead of UAT frequency 978. We've documented together way of how to transmit this information using O-band, which is one of the 3 frequencies we are using in SRD. The O-band is most capable, or actually the only capable of proper functions of these retransmissions. This should provide pilots in countries and areas where UAT frequency is not released to be able to receive UAT kind of information. And this is traffic information, this is weather, these are metal stuffs, and all other information that can be transmitted using standardized UAT protocol. Receive that information using O-band. Thanks to partners, I will name 2 projects, 3 projects actually, but one in Norway, one in Finland, and one in Netherlands. We will be able to assess through this development performance of reception of these transmissions in real environment, because every UAP rebroadcasting or retransmission station can retransmit the same information using O-band. And if you have the two methods how to receive that information on board using O-band and 1078, you will be able to compare these transmissions. Last but not least, very soon, I will not say this afternoon, but literally this afternoon, we have a meeting with telecommunication industry to start discussing seriously about ADSL for mobile, issue 1. But not only that, we will discuss wider range of issues. ADSL for mobile conspicuity is one topic. There are many others. As you can imagine, drone industry is very much interested in mobile networks. So we hopefully get out of that meeting a more clear timing where industry could support us in the development of ADSL for mobile in response to the outcome of this project, which is calling for urgent action in this area. Next slide, please. And now the iConspicuity declaration. As you know, we were trying to address interoperability and cost since the start, and we understood privacy is a concern. So that was embedded in our work before the research project started. Throughout the project, we have learned also one very important lesson. We noticed in discussions with pilots, in private discussions with pilots, they revealed, many of them revealed that they don't want to be conspicuous. They don't risk to be conspicuous because of fear of administrative action or sometimes even hefty fines for even minor breaches of aviation law. And many of them opted for being non-conspicuous and taking the risk of being non-conspicuous in the airspace because of not being followed or chased by the authorities. And unfortunately, this is against our wish that everybody voluntarily goes for equipage, be conspicuous, not only to improve safety for himself or herself, but also to improve safety for all the others. So what we are coming forward with, based on our discussion and in line with principle of just culture, we are building on these principles, and we will come up with a draft text of iConspicuity declarations, which will be targeting primarily national aviation authorities, but also airspace user associations and others who might support. It will be a policy statement focusing on use of iConspicuity related data and information, which is all encompassing, but will exclude severe breaches of misconduct or criminal activities, of course, which is as the just culture is defined in European law. Next one, please. The key principles of the declaration will be that the objective is to remove the fear of pilots to be conspicuous. So we want to get pilots' confidence for conspicuity in the air. And the declaration will aim at not stating clearly that individual breaches will not be tracked, followed, treated. There will be no management at individual level. So, for example, if someone lands 1 minute after the sunset, legal sunset, this kind of things should not be traced and chased individually. Instead, we want this to encompass big data approach, to use the data, and for that, to have a good data sample, we need most, if not all, people being conspicuous, because that data will reveal what actually is taking place in the air. This data should be de-identified and analyzed as a data set, not as an individual flight traces. All stakeholders should be involved in this process. It should be 360-degree involvement and analysis. So not only the NAAs in isolation, potentially ANSPs in isolation, but and airspace users in isolation, but all people together and frankly speaking about the data set and how the things could be improved for those in the skies or those managing the skies. The actions should be agreed jointly to get a buy-in, so to get them implemented, and their monitoring should be transparent to participating parties. The expected benefits, people may say yes, but we are starting to accept some not fully legal or some individual breaches. But we have to acknowledge that the stakes at play here are much larger than just minimal breaches. We can probably tolerate and educate and achieve improvement even on those minimal or regular violations. By more working together, but through broader equivalence, we can certainly reduce airborne collision risk. There is no doubt in that. We have experience. We have FLARM itself on its own proprietary system in gliding reduced collisions significantly over the years. Then we hope to, based on the data, to be able to have more flexible access to airspace because there will be more visibility about all traffic, not only the one which is using transponders. We hope to get comprehensive activity data fed into data for safety. We are missing desperately exposure indicators. And you know, in general aviation, your flights are private flights. People do not necessarily want to share this information with authorities and others. But this data set, if trusted, we can get a significant influx of activity data into our analysis, and it can provide us even more hindsight what action needs to be taken. And last but not least, for the end users, there is a clear benefit that if they are conspicuous, there is a possibility for faster response times for search and rescue. So pilots could be saved much earlier and treated in case of very bad outcomes. And last slide, so this was about iConspicuity declaration, and last slide is just to plan next research, which is already in our European Aviation Action Plan. We will now start engaging with the ATM community, namely ANSPs and Eurocontrol colleagues who are here with us in the room. And we will try to explore how iConspicuity and conspicuous aircraft could contribute to existing flight information services and search and rescue. So we will explore this new dimension, and we will try to find appropriate balance between using the information while not changing the existing procedures, rules, and practices used by NSP, but mainly complementing them with additional flows of information. And we want to discuss with these partners how this information should be used in the context of their operations. I think that's the last from my side, and I hope this gives you some indication of where we want to go after this project. Thank you very much for the opportunity.
Maybe should we go through the questions on Slido now?
Let me check. Maybe we can break for.
Yeah.
We can do a 5-minute.
Okay.
So let me just check. There are okay. I was talking and I have those questions in there. So give me the time during the break. So let's break for coffee.
Yeah.
And then I will activate the questions. We put them on the screen and we will then go one by one.
Yeah.
Let's restart the session now with the question and answers from Slido. Vlado will take his onwards.
Let me share the screen.
There it is.
Voila, we have questions there. So let me go to them. So So from Gianpaolo, thank you for the question. The question is, how does the current experiences with GNSS interferences affect your ADSL strategy? I think this is for EASA to answer, and we have colleagues in the call, but I'll start, and maybe if I'm saying something incomplete or incorrect, colleagues will be able to correct or complement. We understand that spoofing and also jamming of GNSS is a problem, are problems, and more prevalent in the current times. This is, of course, affecting GNSS only driven sensors or features or functions. We have to acknowledge, we have to split here the two scenarios. One scenario is use space, and use space as a serious endeavor would need to consider all of these in the risk assessment processes to be able to cope with situation where GNSS signal will be deferred or jammed or spoofed. So there would need to be, there are certified entities in the process of use space operation, and these problems would need to be tackled there. So I don't want to expand more on that. We have experts in the room who can provide more details. When it comes to outside of use space, we are in a voluntarily environment where we rely on these to be available throughout Europe in most of the cases. And we accept and have to accept the fact that in certain areas, this may not work, as today even GNSS navigation does not work, and we don't consider it being a threat in areas where it works. So we are using GNSS navigation in aircraft most of the places, all GA community, everybody flies nowadays more or less with GNSS, and it works 90+% of time and place in Europe. But we also acknowledge and know that it doesn't work in certain areas. And solutions would need to be developed also for these scenarios, and probably we would need to come up with solutions that will allow for supporting these scenarios. I can imagine that mobile telecommunication services can play interesting role in contingency scenarios in the future, also for general aviation, because as we all know, even though you suppress your GNSS signal on your mobile phone, the mobile networks are able, through multilateralations, approximate your position to a certain extent. So the same kind of principle could be potentially explored in this. So I hope I answered the question, Gianpaolo. I turn to my colleagues or consortium partners to complement.
What I think is that we are not talking about a precision approach. We are talking about situational awareness outside the use space. So it's not that important, and we can complement the ADSL system with the mobile system as well. So we have these informations, and if the information are not there for a few seconds or minute or so, it's not that important then as a precision GNSS approach. It's a situational awareness thing.
Thank you very much. Anything to add, Peter?
Yeah, maybe one thing to add from my side, just for everyone's awareness, we have established a specific task force within EASA that's looking at GNSS jamming and spoofing and electronic warfare, or the effects of electronic warfare on aviation aircraft systems. So it is high on our agenda. I think it's too early to speculate today what the impact would be on this particular project, but please be aware that we're very closely monitoring this.
And thank you, Hete, and Stefan Wolf from Space Project Manager would like to add something.
Yes, just to complete on it, those considerations. We have the plan to provide service information, safety information bulletin, mimicking what has been already done by the team on for commercial air transport operations, sample. But from a drone perspective, this kind of thing will get us. But today we know that especially drones operations and operation in your space will be affected. There is no reason for what we could be more resilient in new space than for the rest of the operations. So we are considering the impact, for instance, the fact that some manned aircraft in new space may disappear, should be shifted or whatsoever due to the interference. That's one of the cases that we are evaluating. And a SIG will be provided considering those things. Please, yeah.
Thank you very much, Stefan. So hopefully we answered all aspects of this very interesting question. Thank you very much. So moving forward, Mark from FOCA, our partners in Switzerland. Did you derive minimum technical functional requirements for the proposed systems, precision, availability in order to ensure that they meet the safety needs? Not necessarily to full extent, as we know in standards. Again, there is a lot of interest in this information to be made available, and I think this will be potentially made available as soon as we start getting the real information from real environments, real implementations. Therefore, we have a number of projects. We will be teaming up through the iConspicuity activity group with those projects, and we will try to be more up to date with their learnings from real implementations. It is expected that we will be evolving the EASA specification and complementing it with information that is available. We don't work here with high level of reliability and availability because, again, this function is not required. In use space, there will be methods and means how to make sure that the safety is ensured. And that could be through knowing the actual performance of the system in use space or through operational procedures. So there are many methods how to ensure safety, and that will need to be tackled in use space airspace. Anything to add from on top of what I've just said? Mark, thank you for the input, and we rely also on your support and in deriving this information or learning this information and providing it with the specification. Thank you. Stefan, question from Stefan. So go ahead, please. You can say it loud.
Yeah, so I would like to know, you mentioned in the slides that there should be a ground station network for SRD 860, and I'm wondering how dense this network has to be. So what is the distance of these ground stations that is required to have a comprehensive coverage also outside of use space, so countrywide, and who is intended to operate such a network? Because it's a lot of cost and maintenance. So any ideas about that?
Not yet. We did not do the research on that. We put it on the action plan that we have to do research for the ground network. Very important because we need the ground network for sharing all the information. Yeah. And that is one of the major steps that we have to answer.
Okay.
Yeah, what I can say here is that valid question. Thank you very much. And this is we hear a lot of times. Yeah. There are two aspects to be mentioned in relation to this. First of all, there is nearly 2,000 plus stations being active today on a voluntary basis as a community-driven initiatives, and they are usually working very well, and they are being financed and deployed by the community's initiatives. Mm-hmm. And we see more and more federations and pilot associations being interested into this topic and financing infrastructure at their airfields because they see potential to improve safety in the vicinity of the airfields. So we can assume that most of the GA airfields or flying sites will be going into this direction. When it comes to background infrastructure code servers, I will just hopefully not reveal a secret of the OGN, but OGN is an endeavor of private individuals who are using public infrastructure, which is publicly available for very reasonable cost. And OGN runs on servers somewhere, I don't know where, and it's most of the time available. I don't know how Safe Sky project or Safe Sky app and now also device are running their servers, but the costs of these servers and accessibility is not significant for individuals. So it's possible to help, and it's already helping today a lot. In use case, it will be industrialized solutions. Of course, we expect this to be low costs, and drone industry expects this to be low cost. In terms of density, we are limited by physical characteristics of transmissions, which are regulated by the spectrum we are using. Experience from real-time world says that air-to-ground reception is in range of 10 plus kilometers. We have receptions often in the range of 30 kilometers when you are direct radio line of sight. However, when you have obstacle mountain or whatever, the range goes down. On this, what we want to tell as well is that if we do things cleverly, we will be able to complement the system itself or protocol with the possibility to retransmit, relay information. Urban from FLARM can tell you, and the paragliding community can tell you stories and experiences about this is happening today. So there is a great potential to minimize the ground infrastructure or to keep the cost of ground infrastructure as low as possible. There is no intention at the moment on our side. I cannot confirm fully for use space, but on our side, there's no intention to certify or standard we want to have a specification and standards to drive the implementation and infrastructure. Okay. And for this use case, IT techniques, well-known established IT techniques should be pretty sufficient.
Okay, thank you.
Anything to add?
For certification, just a word for use space. We need to be careful with the name certification there in that context. But just to say that certainly that will be the responsibility, it's not that's the responsibility of USSP to acquire the information. So then we have to demonstrate that what they get is meeting the performance requirement for the space. So maybe it will not a certification per se, but anyway, the frame of what we need to consider to give a certificate to the USSP, they will have to show that it's good for purpose. That will be certainly the responsibility there.
Okay.
Okay, moving forward, where is my mouse? Okay, so next question from Guido. Thank you, Guido. 21% of participants not using surveillance. Did you dig into the reasons for that?
Yes, we did indeed. A lot of reason is privacy. Knowledge about the systems and the operations. So people don't have very much knowledge about iConspicuity. And one reason is the costs. And the rentals, for example, they do only the minimum into their aircrafts, and they don't put into, they don't invest into the safety too much money. So these are the most reasons for the 22% of the people who don't use any iConspicuity systems. You can see that in the survey in the report that we have on the website of the EASA.
I just dropped it down because I need to do some work here.
So next question. Is this one answered? Yeah.
I hope this answers the question. But more details in the survey report.
Yeah.
Okay, so I'm back with you, answering it in a second. Yeah.
Go to the next.
Oh, Okay, so this one is answered. Okay. The next one. Serge Lebeau, what altitude is considered? And I can answer this. This is straightforward. Because of GNSS, we consider only geometric altitude in here. We understand that ATM needs Sparrow, and we will be discussing this with ATM in these use cases we want to discuss further. But for the basic function and to keep the cost as low as possible and devices as affordable as possible, we focused on the use of geometric altitude only. Okay, Ralph. From DFS, the variety of sensors and techniques brings up the need of quality-oriented sensor data fusion. Who is meant to build that? I can start. This is not for the project because this is identified action item to work on these data streams on the ground. We expect the industry to build the data fusion. There are initiatives and partners who are doing so. The most famous one who is using data fusion is Flight Radar 24. Everybody knows. They're using data from OGN, Open Glider Network, also with other sources. On our end, the GA end, I can say major initiative of Safe Sky app or company who are doing data fusion. OGN is another example of data fusion. There are various sources and various partners exchange the data mutually. So if someone like Radar Exchange is doing multilateration of ADS-B information, they are exchanging the data with other partners. So it's a collaborative effort. When it comes to quality-oriented sensor, the quality in use space needs to be ensured. That's clear, and that has been already answered. It will be ensured through the use space service provider who is responsible for that, and that will be on request of their own businesses. But elsewhere, it will be industry-driven initiatives. I hope this answered the question. Please feel free to ask complementary questions if something is not fully complete. So, a question from Karel. As a GA pilot, I would like to welcome an integrated system, not if it can be avoided, and an add-on system. Skydemon and FroFlight Easy VFR is showing all available data. Yes, this is amplifying actually this comment. It's not a question, it's amplifying what's taking place today. The industry is teaming up. They are starting to exchange and the data. There are data integrators, there are app providers, and they are starting to cooperate very closely. And what we have seen over the last 1 year is that many of these companies, I can name Easy VFR from your comment, they are already showing this information because of the industry initiatives that are taking place. But also what we need to mention here is that even industry is not able to achieve these improvements on their own. They need support from communities, and this is actually what is taking place. There are initiatives aiming at pilots communities to contribute by installing and operating sensors. We see some ANSPs deploying this kind of networks for the benefit of GA users in some countries. And the early results, early learnings from these implementations are very encouraging. So it's not apps or sensors or equipment or pilots, but it's all of us together joining forces and going in the same direction. Hopefully the iConspicuity activity group will be able to achieve that collaborative spirit we need here in this initiative.
There are already so a lot of systems complementing the systems, the VFR, FroFlight, Skydemon, and so on. A lot of receivers which are coupled with Wi-Fi, Bluetooth, and so on, getting the information onto the navigation source.
Thank you very much. Moving forward. Rodolfo, question from you. Could iConspicuity declaration provide guidelines for airspace review in mountain areas where slight changes would prevent breaches without impacting safety? This is exactly one of the points to get data to be able to discuss exactly things like this one. I'm very glad about this question because it highlights need to have data, to have open discussion. Very often, those who can make decisions, they have lack of data. I can tell you EASA has numerous areas where we lack data. So we are using alternative methods best we could to have comprehensive data set of all aviation activities in a given area may certainly drive safety airspace design improvement process locally at local stage and also in the wider context. So thank you very much for the question. Hopefully, the declaration will be joined by aviation authorities. I have good expectations from the discussions with several authorities that they will be on board since the start, and hopefully all aviation authorities in Europe will eventually support the declaration. Here I take the freedom to mention that in the recent FAA Reauthorization Act, the legislators in the US actually prevented FAA to take any administrative action against pilot solely based on ADS-B data. So they've taken even further step fairly recently, and I'm pretty sure some ideas about this have been inspired by what we are trying to do here in Europe. So we start voluntary approach. If there is no authority administrative actions voluntarily taken, but instead of policing, there is safety improvement. And this is what we want to achieve with this. Moving forward, Johan, was a ground system independent concept considered for the air-to-air solution?
Well, actually, we have the air-to-air solution with the flap systems. They're talking already together. We have the ADS-B certified solutions, which are talking air-to-air. And the iConspicuity concept that we set up is not doable without a network on the ground. But the most important thing, if aircrafts come closer and closer, the more important it becomes that an air-to-air connection is there. So I think you have a combination of both.
Right.
It was you.
It was me.
Johan from Eurocontrol.
Yes. So indeed, I heard that statement twice now, and I saw that a ground system is needed, and the Conspicuity concept is not possible without it. And I still want to argue against that because I think definitely it could be possible without that. And I think we could, for example, argue that we now have the SRD 860 solution and the 1090 solution, and we ask everybody to receive on both links, and then you can transmit on one of them if you're going to control the airspace on 1090. If you're outside, you're on. Could be on either one of them, and then we don't need any ground network to retransmit to do any complicated functions, and we could only use the ground network in use space where we deploy low altitude, confined small airspace, maybe where they actually do operate, and there we can also have the mobile function working in that case, right? And then we could, for all the other type of operations, higher altitude, other airspace where it's not, we could have a dual receive function and no dependency on ground network, which would be much leaner deployment. And I was missing it in the paper, which all focused on ground rebroadcasting. I think the ground system could be there as well where needed, and people want to have it on ground, but to force it everywhere is and not even recognizing that we could have a ground independent solution, I think is a missing component in this
The problem with the ground independent solution is that in this case you request everybody to change his environment, to change his devices, because then everybody has to have multi-link receivers. And you have a very big group of users of 1090, which are sending out only, not receiving. And then they have to have the systems as well. And you have a lot of people flying gliders with a FLAM system. They might have the 1090 in, but not sending out that. So the General Aviation with 1090 don't get the information from the gliders. And we have to bring together these things. And in the discussion of the technical meetings where we put in all the transmission paths, we learn you cannot interchange the information in the air. That's pretty hard to do without the help of a network. And you might bring up the network into the air, but
I don't think that is true, to be honest. I mean, if we look what happened, no, if we look for take the US deployment, for example, they said 2 links. They said they deployed the ground network. What happened in the end was basically all of them do dual receive and transmit on one. So they are independent of the ground network, most of the system. Even though they have the ground network, and the ground network is the expensive component. It's easy to say that it's just, people doing it on their hobbies, but when it starts becoming a responsibility of somebody to ensuring the availability of the system and operating it, the cost starts increasing. And I think it's different as well from saying, putting a milestone out there saying, okay, we're not there today, but we aim for everybody to be there when you buy a new equipment and when you design equipment to be dual receive. And then you go there, and then we can mitigate in local areas where there is high density. You can have local rebroadcast where it's needed, and we have a lot of equipment which are not that there today in our target environment. But it's another, that is very different from saying we need to deploy a pan-European ground network, and somebody needs to be responsible to operate that one. And we don't even know the density, the cost, there's multiple questions there. And we could deploy a much leaner solution if we put a mark out there saying this is where we should go, and we should deploy and design equipment that goes in this direction.
But how can you integrate, for example, the hang gliders and the model plane flyers into this system which works air-to-air only? We have to bring this information to the cockpits.
Why not? Why not? If they have an SRD-860 solution, why not?
If hang gliders have the SRD-860 solution, but how do you do it with model flying, for example?
Well, they can put a local transmitter where they are flying and send in that area. You come here.
Which costs about 800 euros or more.
True.
We know that. It's
true. But what does the pan-European network cost?
It's not in relation to the cost of their hobbies, and that's the problem. We want to get a solution for everyone. And
so you're saying,
but you're fixing a hobby with some agency that will need to invest in that ground structure, isn't it?
Yeah.
Just for someone to have a hobby, it doesn't make sense in a way, isn't it?
I think there is misunderstanding in the room here. First of all, the ground station ground network is not a requirement. It's complementary. The system as of the project was highlighting the certified, uncertified world, so it's already consolidated to the 2 elements. Plus, of course, complementary or in-use space only for the network connectivity, mobile network connectivity. The ambition for limited infrastructure target situation should be our ambition. For use cases where investment in infrastructure would be substantial, especially there are remote areas. We will not have always the infrastructure over the seas. We have some seas over Europe, so offline there. So, but we have to distinguish between the needs of pilots. There is one dimension, and that's the rules of the air. Who has right of way? Certain pilots need to see the others. For other pilots, it's more important to be seen by others. And I think the burden of investment will be driven by existing rules of the air. For I give example, it's very little slow-moving paraglider can do to avoid collision with an aeroplane which is flying 120 knots. They can do very little to avoid a collision, and by law, they are not required to take to give a right of way. Of course, the law says everybody is obliged to avoid a collision, but right of way rules are very clear. Aeroplane gives a right of way to unpowered aircraft. So it's far more important for paragliders to be recognized and seen by an aeroplane. So there is probably more a need for investment for the aeroplane pilots to see a paraglider, because the law says today right of way needs to be granted to the paragliding community. What paragliding needs to see is another paraglider, because the law requires another paraglider. They need to behave in a certain way in the air. They need to give a right of way. So that's where paraglider community might be interested to see other paragliders or hang gliders who are similar speeds and similar non-powered aircraft. So there is this equation that needs to be brought, and then when it comes to infrastructure, I think eventually the system will evolve in the way, as we discussed with Eurocontrol colleagues and agreed that there is clearly a need for a direct radio line of sight communication, especially if we want to tackle all airspace. But there is also a need for a meaningful ground infrastructure to be able to process the information, especially for pilots to be able to make more strategic decisions along their trajectory, or more importantly, to uplink information they need for their situational awareness, be it hazards or weather along their route. So this is what the pilots are interested and they recognize. On a short distance, we probably would need to rely on a direct radio line of sight. Heather, is there something we could share about our roadmap and joint efforts with Eurocontrol at this point in time?
I think it's still a bit too early, other than to say that we are discussing with Eurocontrol, you know, the various options that are out there and the next steps, and that also includes discussions on frequency. And I'm sure that we will be coming out to the community and present our views on that. But for now, I think it's a bit premature.
Thank you, Heather. Thank you. So I think very good question, Johan. Thank you for bringing it up, and it will certainly be discussed. Okay, next one from Guido. Frequency problem solved by FLARM. Does this solution involve using one of their proprietary solutions? Heather, and it also
I think that was a hardware problem. It doesn't have to do something with the proprietary solution. If you use the adjacent frequencies beside the SRD band, then there might be the receivers of FLARM run into the saturation, but they put into the hardware some filters. They installed filters to avoid this, so that the usable signal is not is still identifiable. So I think this is a problem that is solved by hardware, not by the proprietary software solution. And
can I comment?
Yes, of course.
If it helps. So this is a situation that is actually not uncommon, and we've seen that, for instance, in the US, where adjacent channels are used for LTE uplink. So it's a strong signal adjacent to the 860 or 950 megahertz band. So all this is saying our product solved that since 2010 or so they can operate safely in the US, and this is nothing to be worried about. I think that's the message to take home here. It's state of the art. There's some filtering you need to put into your hardware. I'm not even sure what the other manufacturers are doing. They might implement this as well.
Thank you for your answer. So this filtering, it's described in any standard?
No, what you do is you do sensitivity testing. The mechanism here is called blocking, RF blocking. this is something a standard laboratory can do for your product, and you need to put in appropriate filtering. And this is nothing fancy. A SAW filter will do.
Okay, thank you very much for the clear answer.
You can write me an email if you need more information. No problem.
Thank you, will do.
Thank you very much to Urban as well. Some from Gunnar. Could a retransmit of data from ATC and from new drone systems be much easier way forward to give GA pilots better awareness about any traffic around them? Yes.
What do you mean with the retransmit from ATC? ATC doesn't have the iConspicuity data yet. We don't have the interfaces for that right now. But how should that work with the ATC data?
I think what's meant in the...
I think it's TISB that you take.
TISB. Okay, TISB. The traffic.
As I read it, you take surveillance data and you uplink it on the new messaging.
I think that is planned. That's already in specification number 2 of the ADSL protocol, the TISB construct, and the FISB as well.
Okay, thank you for answering this one. From Karel, thank you very much. EBF will be involved. You will be invited through your exports to participate. We need pilots associations to be closely linked to this, and we will also rely on the initiatives driven by these associations to steer the discussions and developments. Thank you very much, as it is happening today. Thank you very much, Karel. This is now again from Werner. It's IFA traffic in class eco airspace. Will this system address this also?
Well, I think the Conspicuity, the iConspicuity doesn't have to do something with the airspace usage because the visibility is still there. And if the IFR traffic is using mode as ADSB, then you can see it. And the other way around, it's the same thing. And if you're sending out ADSB, then the IFR traffic sees you as well. So even if it's a SIL of 0, I think the commercial aviation doesn't display this traffic because it's filtered out by their systems. But we have to work on that, how we can react on the display of the traffic in commercial aviation in class eco airspace.
Thank you. The next one is about from Serge. Have you considered ForeFly's Sentry system?
Well, we did not evaluate single systems. We just looked at the principle of the systems, and we saw a lot of developments, even on the aero systems. And we are looking at every single device there, but we don't say that something is good or not. So yes, we look at all these devices.
And I'm not sure I have full information, but ForeFlight Sentry, is it a low power 1090 or UAT system? We would need to dig further, but if it is low power 1090 system, then in that case, this has been considered and discussed in the technical meetings. And there are some regulatory obstacles to implement that in all Europe. So, but we are in discussions with our colleagues in Eurocontrol. We want to look at this opportunity. Okay. Question from Paul. Could EASA make a leaflet for GA pilot explaining the need and the different ways to be conspicuous? That would be greatly help Federation to spread the word. Paul, I fully acknowledge this call, this request. This is indeed what was revealed by the project, that there seems to be lack of comprehension and often also information about what conspicuity is and how it should improve. and how pilots could participate. We will be building on the results of the project to put more information on the website, but I will highlight here that we will need to do it because of constrained resources on all ends, not only on EASA, but also federations, associations. These are all volunteers. We would like to make it as a team effort. So once the iConspicuity activity group is established, one of its tasks will be to promote also on the EASA website the information about how what are the ways to be conspicuous, what could work as a minimalistic solution, what could work as ideal solution for pilots. So pilots are more aware about what is the ideal solution for their use case, because there are many individual use cases and regulators doesn't necessarily know what is the individual use case of the pilot. So instead of trying to impose something on them, it's a better way to explain what they could do and what is the best way to do so, and in their circumstances they will make their own informed decision. We will be teaming up with you guys and others to promote IDSL coalition and ways to be conspicuous, and also we will put more effort in this iConspicuity declaration once the draft is being finalized. Thank you very much for the question. So from Jose, the fusion of certified with non-certified ADSB signals can lead to various problems, priorities, duplicates, and so how to solve it?
Well, if you connect your mode S transponder with a GNSS signal and it's upgradable, then you get a single ADSB out signal, and that's not a duplicate. So how it should work? You get a hex code there for your aircraft, and the only thing is that in solutions like mobile apps, you often have the problem that you have duplicates because of different transmission paths that are coming into the system, and you have to filter out which it is. So if you have the mobile app in your own aircraft, you can filter out your own device. But if you are sending out more than one transmission path, like 1090 and together with FLAM and something else, then other ones receive different signals of you. That's true. It's still a problem to filter that out, but not with the ADSB signals.
Yes, and this is known problem. Thank you, Jose, for the question. There are ways to address it, for example, through unification of address. We will need to look at this, how and what unique address could be used to avoid the problem of duplicated visualization of duplicated transmission. I don't think the problem is that if you are transmitting from 3 different sources or 3 different devices in one aircraft. The problem is how to comprehend that information on pilots and how to process and use that information. The good thing on ADSL is that we have a timing information there, so that could be used for prioritization, what is being processed and displayed. But if there is no alignment between the various sources of transmission, then we would need to probably use either method to subscribe to a unique address and all devices to be aligned to that address. I know from apps, they are detecting other transmission in your vehicle, and they are actually actively prompting pilot about the device being in the vicinity, and then the app can align itself to the ADSB transponder, for example, so it stops warning pilot about duplicated transmission, so it knows that there is an aircraft. I know from FLARM that there is a setting that pilots can set a tow plane, so there are no nuisance warnings where the glider is in a tow with a tow plane and things like that. So there are many different ways how to tackle this problem. There is no single silver bullet solution for this, but potential development could lead to something towards unique ID being more harmonized. Okay. Question from Werner. Having new hardware in the cockpit will offer all these opportunities, but the associated cost could easily be several million euro for the GA fleet. Any comment? I think all the efforts illustrated in this project were aimed at using existing hardware to the extent possible. The first steps in a mile were achieved by some existing manufacturers now offering the software update for the devices. That's a start. There are more new devices also being available. We also have noticed that some very old devices have some of them are getting poor performance. So there may be incentives for pilots to change after 15 plus years of using the device for something new. We haven't calculated the associated cost, but was our ambition by EASA before the project, and also ambition of the project at all its stages was to keep associated cost at minimum. What we also discussed and concluded is that the basic conspicuity function should be minimal cost, but pilots could probably be willing to pay more in case they get additional services, additional functions. So I can imagine that the basic conspicuity function, we know that it's free up today. You can, if you fly low within the connectivity of mobile network, and you don't have your own plane, but you fly using various planes which do not have a conspicuity device, a smartphone app solution is a solution, potential solution to you for those people. But of course, if you want to benefit, if pilots want to benefit from additional information in the cockpit, we expect them to do some additional investments, as it is the case today for many weather-related data subscriptions and similar things. So I hope this answered the question. We really want to keep this as minimal as possible, and we really want to reuse the existing equipment to the extent possible. So by minimizing the specification requirements.
Maybe, Vlado, if I may add to this, from the very beginning, it has been our goal to leverage on the fact that this community, has invested in tens of thousands of pieces of equipment voluntarily because the community believes that it's improving their own safety. So outside of the use-based environment, we're not looking at mandating anything. What we really are trying to do is to make sure that all the different devices talk to each other and see each other with the goal to provide recreational pilots primarily with improved situational awareness. That's been our aim from the get-go. We're not trying to force anybody to use different applications. We really want to leverage on what's already out there.
Thank you, Hete, for these very important words from the top expert on avionics. Very, very, very encouraging to hear that. All right, so the next question is from Pantelis. It's on the screen now. What about ADSL in ATCs? As of now, ADSL remote ID will be invisible to the controller. I think we need to clarify here a few things. First of all, remote identification for drones is we will be inserting it into the specification, not to serve ATCs or someone else, but solely to add additional optional possibility for drone operators to track or visualize their drones using SRD860 spectrum. So that's a drone topic, and we are discussing here in this context the GA topic, and there is no remote ID there. However, there is also the other dimension of this question, which is ATC. I can translate it as air traffic control. There is no intention to use Conspicuity function for any credits for air traffic control at the moment. There is not even discussed. I will refer to the primarily objective of conspicuousness is situational awareness. What we want to do, and this is to clarify what we want to achieve in terms of ATM, air traffic management, we would like to complement existing services, flight information services, and search and rescue services, operations, with additional source of information, and we would like to clarify how that information could be used safely in the context of current operations. So instead of neglecting that information that is available broadly, including on the internet, we will be looking together with partners in ways how that information could improve also situational awareness of partners on the ground, which are managing the traffic or providing certain level of services. So I hope this clarifies. So there is no intentions that controllers will be controlling drones by seeing remote identifications. Probably many of them will suppress this information as disturbing because they will focus on traffic that they control or they manage. But we will be looking at ways how that information to be available, especially from manned aviation. When it comes to drones, there are different actors who need to get this information. Okay. Question from Urban. Use-based adoption seems to be more sluggish than expected. How does this influence your plans and timeline? Thank you, Urban. Very spot on. We've learned from early implementations of use-based that use-based is a serious endeavor. Most importantly, it needs to be business-driven, so there needs to be real business needs from drone operators to operate in the same airspace with more dense drone operations. It has a positive, this delayed or slower than maybe expected deployment has positives and negatives. I will mention a positive side, which is use-based is the only mandate we are considering for electronic conspicuity, and as such, it doesn't create too much fear out there in the community and panic that use spaces will be suddenly everywhere and people will be affected significantly. Negatives of that is that our only incentive, regulatory incentive we have, may also drive less adoption of by conspicuity devices, and that's a negative point. This negative point we need to try to overcome by better informing pilots, better promoting solutions together, by removing additional concerns why many pilots are not equipped. We have seen through the good experience in gliding years ago, where FLAM started, Urban, that there was a lot of reluctance to adopt solutions like FLAM by the communities, but then there was a breakthrough point where more people started to be equipped, and people using devices like FLAM were able to detect other people in the skies, and they noticed that they have suddenly seen something they haven't been noticing in the air before when they were not using any device. So this has driven, so own experience drives the behavior of pilots. And more importantly, in these communities, those pilots that were not equipped were even more encouraged by other pilots to be equipped, because it's a community sense, it's a community safety that drives the positive influence. So we do not need to always rely on regulated or mandates, but yes, indeed, use space has two dimensions, positive and negative, and I think I explained that enough.
Vlado, I would like to react on that. So Stefan Gobor, Use Space Project Manager. So Urban, I would like to reflect on yourself. Why this place? Because here today, I can tell you that I am certifying USSPs, and about Conspicuity, we have no data. So I'm going to put a limitation on the certificate saying no operations in use space potentially designated in uncontrolled airspace. Why? Because somehow you are also dragging and you are not providing the information which will increase the path of the implementation. The two first questions were absolutely excellent about performance requirement, drivers for the ground infrastructure, coverage, etc. The member states lack those data. So if you are not making an effort to help them say, okay, that's the best performance requirement you can obtain with, by the transmission over SRD 860, for instance, they will have difficulty to make those evaluations. Same thing for the consideration and coverage, and even more when we touch the USSP. They are not CNS provider, and they have difficulty to make this assessment for themselves. So if you are not able to help them, then for sure, what will be the answer of the industry is we don't go there. So no business for you at the end. Second, you have published the issue 1 of the specifications some time ago already. The industry is waiting for the first demonstration and the first equipment to be available. If nothing, it's a kind of a chicken and egg situation, but many of the member states and stakeholders to whom we can discuss, and Vladimir has been part of some discussion with them. They are waiting for the first real demonstration, and then they will have a guarantee that the system performs well, let's say like that. Maybe they will start to invest in analysis and designation for uncontrolled airspace. But really here you have absolutely a crucial role to play in the designation for use space airspace in uncontrolled airspace, is in providing all the data and to support the designation. Voilà, that's the message I want to pass. Because today, clearly, I have no prognosis of use space airspace in uncontrolled airspace for those reasons. Nobody knows when and what will be the performance of it. Yeah. Over to you.
Thank you. Urban, do you want to add on this? If not, yes?
No, I'm fine.
Okay,
I'm fine, thank you.
Good. Another one from Pantelis. What's the need of so many systems? Isn't ADSL enough? Is in the US there are only ADSB and UAT? Is ADSL going to be mandatory? So we agree, I think, all that we should minimize the number of systems. There can be many systems if they are interoperable. We don't care about number of systems. We care about number of languages we call this system talk to each other. So we try to minimize that. When we started to develop ADSL, the starting point was ADSB out, and to extent possible, or to significant extent, the ADSB out and ADSL are close enough to work together or to be processed together. We are in discussions how to make this convergence or alignment even closer. But we also need to recognize that ADSB is pretty, it's much more conservative, much more difficult to change ADSB international standard than to change the specification of ADSL. And there are additional needs that are not being considered by ADSB out. For example, timing is not there. while ADSB has some additional information that are not necessary for this use case. So what we are trying to achieve is to have a EASA specification that can be accommodated by existing devices that are transmitting with numerous other protocols. And we instead of adopting one of those protocols, we try to have something that can be commonly accepted, but at the same time we recognize that, for example, we've been discussing FLAM. FLAM provides additional functionalities to pilots on top of being conspicuous. And of course, we are not trying to regulate those like collision warning or proximity warning. We are not there yet. Therefore, we have to recognize that there are and there will be some additional protocols that are used by communities for their own purposes, but we want to work with them to converge as much as possible and starting initially from basic conspicuity information. That is also, among other things, required for the use space access in radar control. In terms of communication frequencies, we try to simplify this as much as possible, and we will continue these efforts on spectrums, and hopefully this will lead to even more simplified solutions after the projects. But the project did good work in trying to simplify the scheme and recommend the approach of certified, non-certified world to acknowledge that there won't be only certified world in the future, but we need to acknowledge that there will be also other world, and these two worlds need to use the information available the best way they could.
And if you look at the ADSL protocol, it has at least two transmission parts, so mobile and SRD-860. And the last part of the question, I think you answered that one question before. It will be not mandatory. It's a voluntary.
Yeah, and ADSL is one of the methods to transmit in use space when the mandate is. Another method is ADSB out and UAT if it is agreed in Europe. We don't see it happening in coming years. So we will see where this goes. But ADSL is mandatory only in use space when the use space is established in uncontrolled airspace. When people operate in CTR, for example, when they are subject to ATC, then there is no change. Okay. What was the date to have a ground station specification requirements? Good question. The focus of the previous work was on the requirement in SERA 605, and that sets the transmission method. So we did that part. There is a lot of work done on the reception side, either by community initiatives. There is a lot of work about OGN receiver, but also there are industry partners. There are a few companies in Europe who are focusing on this, and they are deploying receiver. This has not been yet standardized. We have provided minimalistic approach in ADSL. In issue 1, you will find a receiver code example, how that information could be received. From industry partners, I understand that this is not a rocket science to be able to receive ADSL information, to receive ADSB information. It's commonly available, so that should not be a problem. But in terms of specification of the equipment and ground station, we for the function outside of use space, we do not expect that. Receiver station specification may come up through use space development or maybe eventually to ATM, but at a later stage. So it's not planned at the moment. Am I missing here something, Stefan? We don't work yet, and we don't plan to work on ground station specification, so yet.
Indeed, not for now.
Thank you. Correct. Okay. Next question from Libby. Assuming mode S is always transmitted by GA aircraft entering the U-space, in that case, can there be an advantage to ADS-B over mode S?
Yes, so it's the position information. ADS-B includes the position information, and if you're transmitting mode S in the U-space, this is mostly it's uncontrolled airspace, and it's a lower airspace, so it might not get reception of the secondary radar. So the mode S information is completely without any position information, at least if you don't have multilateration systems. So the ADS-B system is integrated there because you need the position information.
Yeah, so pure mode S without ADS-B or GNSS information, it's not eligible as a means of conspicuity for U-space. However, other systems like ADSL or most simplified, non-certified GNSS source as input into the mode as transponder, which is capable of transmitting coordinates, is possible. It's eligible. So that's the distinction. Thank you very much for clarifying that. Next one, Jose. Is enough to provide safety coverage in U-space zone to rely on the infrastructure of non-certified station or combined with certified ground stations? I'm not aware of any certified ground station, maybe standardized. Even ADS-B receiver stations are just declared against the standard, they are not certified. Those who use that information are certified. ANSPs are certified entities, but the device itself or equipment itself is not certified. And as far as I understand, even for surveillance purposes, it's not intended to be certified, but declared against industry standards. I think the same goes for U-space. It's the U-space organizations, USSPs are being certified providers as well as common information services, but that's a different partner. So all the device and infrastructure will be used. I can imagine both ADS-B standardized or non-standardized stations to be used in U-space in combination. I think there is no comment, so I am moving forward. This is from Michael R. It's copied from the chat. Yeah, great pleasure, Jose. Is that 77% of all transponder types or 77% of the total number of transponders installed in the aircraft? So this survey.
Yeah, that was a question of our survey. We asked the 5 major manufacturers of transponders in Europe. We got answers from 4 of them, and one was not really usable. So 77% of all the transponders built in it was not only type related, it was just the number of all transponders which are upgradable, which are already sold and I guess installed in the aircraft. I hope that solves the question.
Thank you. The next question is from Florian. That's for you again.
Will the complete survey results be shared with the public and or the CAs? Thank you. Yes, of course. They are on the website already.
Florian, do you want to complement? What level of details are you looking for on top of what's being published?
I think on the EASA website there is the complete survey report. So all the information that we have.
Okay, so Florian, if you need additional information, please don't hesitate
to the question. Yeah,
to contact for more information. Thank you. Good question.
The link is to the website is in the chat, so you can also just click on that and download the survey results.
Okay, we have a next question from Serge. As for business aviation, safety is paramount. It might be of interest to consider EBA in the future activities. Absolutely, yes. What I would like to mention here that EBAA was being considered to be involved in initial development of compliance to U-space, but then it was considered that EBAA was fine with AOPA and Eurobest was being in the process, and they considered that the participation of those stakeholders will cover also needs for EBAA. But EBAA is member of stakeholder advisory bodies. It's one of the major stakeholders, and EBAA will be invited to participate in Conspicuity. And thank you for expressing this interest. We very much wish you being involved in all of these discussions. Thank you. Question from Mark. Existing affordable low power ADSB and UAT certified solution is on the market. Why do we need new no certified, for example, that may not guarantee minimum performance safety? That's a good point. Maybe you start.
Okay. First of all, you tell us that there are existing affordable low power ADSB systems that are certified. I think they're not certified. They're not usable in Germany, for example. So the certified equipment is the ADSB equipment that is integrated in our target system. I know, I think these are from Great Britain, these things. But we have not the safety performance guarantees. We did not test that. We are just looking for situational awareness here and to get information into the cockpits that we didn't have before. So I guess maybe you can complement.
Yeah, definitely. You've answered most of the question. Just to make sure that low power ADSB or UAT transmissions are not allowed in all Europe. First of all, low power 1090 is not allowed in Europe because it would require filing difference to ICAO to international standard, and that would entail agreement of 27 plus additional EASA member states to support it unanimously, plus that's aviation part, but also telecommunication regulators to support it. So that's a serious endeavor, but we will be looking at that as well. Second dimension of this question is that there are tens of thousands of users who invested in non-certified solutions voluntarily to improve safety. And from their perspective, the existing performance of existing system is sufficient enough for better situational awareness. And instead of imposing something on users from the regulator's perspective, we have taken a different approach, and we've engaged with these communities, manufacturers, and tried to come up with something they could develop as an industry initiative. ADSL was drafted, the specification was drafted by industry with participation of EASA, but it was drafted by industry. And we will continue in the same way to make sure that whatever comes out is acceptable to the communities, because that only adapted solutions drive safety. If we have a fantastic UAT solution and we cannot use it in Europe, or 5 people are not buying it, we will not achieve progress and improvement. But if we will work with those who already made the effort and investment and burden, and try to adapt those systems or maybe update their systems, for example, just by simple software change, then this is the way how to get more acceptance. We want to get it nearly full acceptance voluntarily, as discussed in the presentation. I hope this answers the question. Question from Werner. Any chance that the new system will also offer up the possibility that I could get awareness about large commercial aircraft also on the screen?
Yeah, it already works. Because you see the ADSB and Node S systems on the most systems. And if you look at the application, the mobile apps, then you can see a lot more. So I think it's already solved. You can see this aircraft.
Yeah, I will just add very little. These aircraft, if they are transmitting on 1090 with coordinates, meaning ADSB out, certified system, reception of that information is license-free. Everybody can receive that information, and this is already happening. And I think Werner knows this very well. I think the point in this question is those users that are not transmitting ADS-B out. By the way, large aircraft, all of them are mandated ADS-B out, so they are transmitting ADS-B out, therefore we see them. But there are many users, as in your study, who are not having transponders capable of transmitting coordinates. I think Eurocontrol colleagues have estimate of 18,000 or 25,000 users in Europe.
Can you say again? Sorry.
How many Mode S basics surveillance?
ELS without, 26,000.
26,000. So that's the estimate where we've got from operational environment. So there are 26,000. According to the studies, more than 70% of these units could be are updatable to these basic coordinates with lower quality levels, still 0. But there is a need to find solution for the others. And one of the ways potentially could be, and this is, I think, where Werner is pointing to, is that ANSPs will be more open to share surveillance data or de-identified surveillance information with the communities or with the industry involved in the conspicuity.
Multilateration data.
Multilateration, pure surveillance, for example, and things like that. And we have to also note down that the MODES is not mandated everywhere in Europe. So there are areas in Europe where they are still using Alpha Charlie, and also all that information could be useful in this context. So, but that's to be seen. We will engage with the NSPs at the end of this year to see what's possible to achieve there, without compromising privacy or safety of their users. All right. In your question, DAA was project, but surely DAA relies on the output from this project in order to function reliably and consistently. Yeah, I take this as a question. Yes. I'm not an expert on EAA, so I will refrain to go into the detail, but I can have the same feeling as you have, that there could be benefits for the EAA if there is a mandate to be conspicuous, because there is additional safety layer in the system that can compare to non-conspicuous traffic. So then it's easier to distinguish the objects in the sky. Is there anything else from my colleagues to be added on this interesting and
Yeah, maybe I should add a few words, Vlado. So the standards for detect and avoid that are in development today are looking at the use of air-to-air radar and electro-optical sensors to detect traffic that is not conspicuous. And conspicuous in the current standard means that it has either ADS-B or that it's transponder equipped or has ADS-B out. And that should be sufficient for the initial operations. That's not to state that in the future, if we really see, ADSL being picked up, if we really see that all these devices are clearly visible, that they meet a certain level of performance, even if we don't, necessarily have to specify what that level needs to be, we will be pushing the standards to include sensors that will pick up, for example, these signals on SRD 860 simply because it will improve the performance of the detect and avoid system. But for now, I think that's a bit premature. We first need to see how this evolves. We first need to see how well the DA systems will be performing with the sensors that are currently foreseen. And then we can ask the question of whether we should expand the sensor suite, so to say, to also include these type of devices. I hope that answers the question.
Thank you, Hete, for taking. Yes, go ahead.
Maybe I can add some more information. So Guido Manfredi speaking. I'm the chairperson for the working group 75 working on ACAS-X. We are trying to make sure that at least on ACAS-X side, the detect and avoid system that are being standardized include compatibility with ADSL. So we are trying to push in this direction in order to have an input that is already there and just wait basically for the sensor to be ready in order to use it. Now, one of the issues that arises is the fact that the GNSS information might not be certified, and that's been worked on in the working group 105 and SC228, how to use non-certified GNSS positioning. Currently, there are some ways like completing the detection with another detection from a trustworthy sensor, but there is no conclusion yet. That is part of working group 105 and SC228 work road, and they will be publishing a report on that, or at least a white paper.
Good, thank you. Guido, thank you very much. And Hete as well, as I said. Good question. Another one from Mark. Wrong or low quality info can be more dangerous than no info. How not certified ADSL will guarantee quality so that pilots don't take wrong, dangerous decisions?
Shall I say something there? Well, it's still situational awareness here that is turning around, and there will be no guarantee. And the iConspicuity just supplements the see and avoid principle. So if you get information on an iConspicuity system with ADSL, then you have to look out in the right direction. And if you look out and you don't see anything, you don't take wrong decisions, because you take your decisions with the look that you have, and you're not flying IFR. So
Yeah,
it's just a supplement.
Yeah, and I will just add that we have more than a decade of experience of using these systems, including warnings. And I can tell you that communities that are using these systems, they are quickly leaning towards solutions that provide better solution for them, less false alarms or no false alarms. So there is a business-driven environment. It's a competitive market, and those solutions that will provide low-quality service will be eliminated by market forces. This is what we've seen in this environment. So I'm not elaborating. This is the matter of fact, and true that it's not 100% perfect, but these developments and industry and stakeholder involvement drives improvements to the very reliable system for the purpose it's used, which is situational awareness. Thank you, Mark, for the question. Question from Libby. Want it to be simple to upgrade the basic mode S transmitters into enhanced mode, simpler than AT and ADSL light capability?
Well, that is the way that we do it. The ADSB out function is the extended splitter, that you upgrade the mode S to ADSB, and we won't bring in the ADSL capability into the mode S transponder that we have right now.
Yeah, and to just complementing what Helder is saying is depends on the perspective of which you are asking question. If you are asking the question from the perspective of owner of mode S transponder, the research showed that 77% of those owners can update very easily for ADSB, simplest ADSB out that is allowed in use space. So that's a simple solution. I did it for my plane personally, and it was pretty straightforward. There is standardized change in CS STAN designed for this especially. But the research also relieved information that there is 26% of those 26, around 26,000 people who are transponders, which there is no technical possibility to upgrade that system because these are early versions of modest transponders. And of course, the solution for those people would be either to change the transponder for the one that is capable of doing so, transmitting GNSS, or complementing the system with ADS Lite capable system, which is some of them are already on the market and were displayed on the slide already. So this is how the solution exists today. There is also possibility potentially, and we are exploring that possibility of lower power 1090 transmission. This is the device used in the UK and I think also in the US, which is U80 frequency. But there we are constrained by the licensed spectrums, certified spectrums these devices are using. We are constrained by, in Europe, we cannot file as EASA reference to those international standards, while individual countries can do so. Okay, that's the question. To answer to Libby's question, then a question from Mark, and that's, I think, very relevant one. Glad about this question. I didn't mention it in my presentation. I have draft after review, internal and review in my mailbox. I was on vacation, unfortunately, otherwise it would have been already distributed. So you can expect ADSL issue 2, ADSL for SRD issue 2 draft version to be shared with the community we have contacts to hopefully next week. We will be sending it to all contributors and partners we know, but we will also invite them to share the specification if they know there is someone involved in this field and interested in receiving the specification. So if you do not receive the specification within the next 3 weeks, please don't hesitate to contact us. Helder's email is on the website, or you can contact directly me or consortium partners, and we will make sure that you receive the draft. We will be giving good several weeks for the review of the draft for the community to provide feedback. I hope this satisfies and answers the question. Question from Tristan. Thank you very much, Tristan. What about military traffic flying in our same airspace?
Maybe I think it's a bit complicated because they have other devices in their aircraft, and I think they already talked about the usage of ADSL as well. I don't know how the state on the military things is right now.
I can complement this because this was discussed during the development of ADSL. I need to mention and emphasize one thing. The European Defense Agency was part of the development process since the start. They are actually looking at conspicuousness seriously. They have actually conducted 2 studies on the subject on their own, and they have been able to align their views of 27 member states of the European Defense Agency to provide guidance material for their members how to deal with requirement or with the implementation of use space, not to be blocking use space because there is a need of state or military aircraft sometimes to be completely non-conspicuous. So there is a guidance material about that. When we talk about outside of use space, Tristan, your point is very correct. Here we see developments going into 2 main streams. Military and state aircraft that can be sharing their position, for example, as an aircraft without registration or indicating they are military. They will probably utilize also these developments we are working on, because if it is affordable for individual pilot, it can be affordable for military, but we understand also on military side, and we have some good experts in-house who can tell us how difficult it is to procure, install, and start using some of these devices. But military EDA is actively looking into this dimension. And there is also another dimension which needs to be mentioned. If all of us, if you are conspicuous with standardized technique out in the NES space, this provides certain level of protection to the pilot that he will be seen and detected by defense or state actors, because they will be able to detect that there is an object in the sky and there is a pilot on board or persons on board of the vehicle. So it's a twofold. We cannot probably expect that military traffic to be always visible. We have to accept the fact that they are operating in the airspace, and sometimes the nature of operation requires non-conspicuousness. But we may see being more protected by being conspicuous, and some of the traffic probably conspicuous also to us. Right, and I think this problem will be also addressed in use space dimension, and probably some solutions will be found in use spaces, new space implementations. And I think we have, we don't have last question, so we have 4 more. Okay, so we have now some additional questions, but I'll first tackle this question from In. So you didn't mention ADS-C, which appears to offer a higher level of data integrity. This is likely to be required for use by ATC too.
Yes, I think ADS-C is linked to data link, and we did not use that here because of the costs.
And also ADS-C is targeted for different user groups than it was targeted in this project. In this project, we were looking for uncontrolled traffic, flying typically lower levels, GA, rotorcraft, often community that is completely outside. So it was not in focus. We can confirm this ADS-C was not focused in this project. Yeah, that's correct. There's a question from DGM. From an economic viability, how will USSP be able to take over iConspicuity certified infrastructure or similar solution? BVLOS ops very limited to cover. Okay, so this tackles mixed 2 problems. I think USSPs are entities that are operational in use space, and then the infrastructure there is not certified. It is the use space service provider who is certified entity using infrastructure that is matching the safety levels and performance requirements of use space in a given scenario. So that's one thing. When it comes to BVLOS operations outside of use space, this project was targeting general aviation and collisions of GA where people are involved. We are not necessarily diving into the drones versus GA operations, because there is overarching requirements drones to avoid collisions with manned aircraft, any airspace, use space, obviously, but in any airspace. Outside of use space, drone operations beyond visual line of sight effectively can happen only in low traffic density environment, in which you can translate in practical terms into the airspace that is typically outside of any aerodrome or landing site for manned aviation, lower than probably 500 feet, so where typical operations do not take place, and in rural areas, so not urbanized areas. So this is where potentially the specific operational risk assessment, or SORA, can allow certain individual drone operations to take place. When there are two drone operators in the same place, of course, this is not covered by SORA, and use space would be necessary, or separation, strategic separation of these operations would need to take place. In these kind of operations, drones can operate BVLOS, and of course they can benefit from information about conspicuousness of other traffic. And they could, there are sensors that are affordable for drone operators to be installed on drone. The drone can collect this information about conspicuity of surrounding traffic. But we see some drone operators also deploying some temporary infrastructure when they are operating, and or occasionally also fixed infrastructure, low-cost fixed infrastructure to collect conspicuousness. So these are the various dimensions of this problem, and we see things happening. So it's not millions of euros. It's very cost-effective in many cases, and really drone operators do what is necessary to ensure safety of their operations, so they don't hit manned aircraft, and they do minimalistic, but they do what's necessary. This is driven by the specific operational risk assessment, or in use space it will be driven by a specific assessment in use space. Anything to add?
No, what you said is absolutely perfect from the use space perspective. Just to say that, yes, that's the usual discussion about the cost, etc. There is an infrastructure to deploy, somebody to bear the cost. That's clear. But what is also emerging are intermediate business cases with new companies. They call themselves a supplemental data surveillance provider that will bear the cost of the installation and reshare the service to the USSP, for instance. So the USSP will not be on the front line of the installation of the infrastructure, but will rely on third parties to make their job. And those third parties are CNS specialists. So certainly that will be, in my opinion, the most efficient way to foster the implementation or dissemination of geospatial space in uncontrolled space. And those will have to demonstrate, those external companies will anyway have to demonstrate that what they provide are meeting performance requirements, data quality requirements, sure that it's not totally unusable. But beyond the question mark there are new business models that are also emerging to accommodate that problematic.
Yeah, thank you for this additional hindsight. I learned something new as well. Myself, very good. Thank you. Thank you, Stefan. And thanks for the good question.
Which also have to be paid to you.
Yeah, sure.
Yeah.
Share
Okay, so from Jose, we have 3 more to go until we complete the list. There is no more questions in the queue. ADSB performance of certified stations is measured using PU-PLG Insight service volume. Will be similar indicator for non-certified stations and or ADSL. We are not discussing this yet. We will need to look whether the same methodology or metrics could be used for ADSL for the performance of stations. But as we said, we are not certainly working on the ground stations per se from the regulator's perspective. We more rely on the industry to take the initiative and offer some compliance methods to the authorities when they are deploying this infrastructure and using it. Stefan, is there something we can complement, or Hete maybe? I don't know, this is too detailed for me. PU-PLG, I can translate it. Or colleagues from Europe.
Well, it's probability of update and probability of long gaps. So there are 2 metrics that are used to make sure you have good deployment of ground stations, that you have good coverage and good detection, decodability of the messages. So you use those metrics to make sure that you can have coverage in your.
And do you think this is usable in the context of ADSL?
I think it's usable regardless of the sensor you use. That you need to make sure, so your coverage in use space, you would need that type of metric to make sure that I have a continuous good flow of the data that I'm using for the configuration. Yeah.
So that's I hope this clarifies the question, and indeed these methods could be useful methods also for users. Good. So there is, especially when there is experience with those in the past. Yeah. Question from Niall. Doesn't voluntary conspicuity mean no integrated airspace? What I understand use space to mean at high level and BVLOS US flights at scale. I don't know what is meant in the question under integrated airspace. I would rather talk about integrated traffic, so share the traffic sharing the space, same airspace. Integrated airspace is not ambition of this project. Ambition of this project is provide situational awareness, this basic level, minimalistic level of awareness, regardless of the airspace class, regardless of airspace, any airspace. And that was one of the primary goals of these projects, how to translate these kind of three methods of conspicuity in use space, plus many other methods and protocols and devices, into something that can work in European context in any airspace. So from that perspective, we are trying to make sure that what we are proposing outside of use space is consistent with what is required for use space. And it looks like from the outcomes of the project that little bit more demands, slightly little bit more demands were put on systems operating outside of use space than in use space airspace for main aviation. One example of that, in use space airspace, you can be mobile telephony only once the ADSL for mobile is published, while that is not anticipated in any airspace. We know that mobile networks, at least today, they are not able to provide this connectivity at flight level 80, 60. Probably in the future, maybe, but not any airspace today. But in use space, it's understood and confirmed that this will be sufficient solution for these initial implementations of use space. So that's one distinction between use space and non-use space environment. But the ambition of this project was to look at any airspace inconsistency with use space from the perspective of manned aviation conspicuity. I hope this clarifies.
Flado, if I may, I read the question a little bit differently. There is no voluntary conspicuity in use space. There is a requirement for any manned aircraft operating in the use space to be conspicuous. And I think that we should be careful not to mix the voluntary nature that we used and that we appreciated and that we used as the baseline to say we're going to continue to work with the equipment that people have voluntarily installed, with the performance of the system and with the need to be conspicuous in use space. Even though we do not specify ADSL equipment to the level of detail and we do not formally certify it, that doesn't mean that those systems do not have a required level of performance that should be suitable for operations in use space. And I think I want to make that very clear. We're applying a different approach than traditional certification, but that does not mean that the performance necessarily is worse than when we would be certifying this equipment. Back to you.
Thank you, Heta. Very clear. Thank you, and also very important statement in this context. You. And we came to the final questions from Rodolfo. Can you please clarify if and how associations can contribute to the working group on iConspicuity declaration? So thank you very much for this. This clearly shows that there is will and interest in this development from the pilot's perspective. What I can say is that we will first draft this text of we need to first draft this first text of declaration internally in EASA. Then we will share it within our stakeholder groups, meaning General Aviation NAA's representatives and General Aviation industry and associations representatives for comments. and we will invite them to start discussing within their organizations if and how they can support. What I expect, I can tell you from the informal talks I have had with some NAAs, there are some NAAs willing to support the declaration as framed today since the start. So we may have initially EASA and some NAAs already be on board since the start. And we have some GA associations also very much interested in. So I can imagine that provided that all the concerns and points will be addressed, Europe Airsports and their members like Balloon Federation, Microlight Federation will join the community, will join the group of those declaring they are supporting the declarations, and we will make it public together with them. But I can imagine also national associations, air clubs of users joining at a later stage, of building on the example of their local NAAs, national NAA, national aviation authorities, or their pan-European umbrella organizations. So it's not going to be restricted, and it will be relevant to any partner for whom the declaration makes sense from their perspective. I can tell that we have presented the main skeleton of declaration even to investigation authorities, and there were no negative comments. I would say contrary. So this seems to be also welcomed by the community of those who make lessons learned from accidents and incidents for us. And I think that was, there is still one more question, which is good. So, Gianpaolo, back in 2020, Goodman GSM Association launched a joint initiative. Yeah, this is, yeah, okay. Thank you very much, Gianpaolo. This initiative is aerial connectivity joint activity of Goodman GSM. One member of this activity is in the room here with us, and some others we were in contact earlier. And this activity was aiming for the drone industry and mobile telecommunication industry to join forces and to demonstrate how mobile telecommunication services could benefit how drone operation could benefit from mobile telecommunication industry standardized services. Very inspirational also for our decision to support mobile telephony by EASA in this initiative. Certainly, these works need to be reactivated. We will be reaching out to the industry, and we will have discussions with them, not only in the context of electronic conspicuousness, but also in the context of potential use of mobile telephony for command links, C2 links, and population density and other things as publicly known. I hope for some meaningful progress on ADSL for mobile to be achieved, hopefully sooner than later. So that's what I could say on this dimension, and thank you very much for Gianpaolo for raising this topic for the attention at this meeting. That concludes the question and answer section here. It was pretty long, but pretty interesting from my side.
Thank you very much for the questions.
Okay. So I believe this concludes this important milestone, this project. It's not the end of the iConspicuity, but it will continue internally and with our stakeholders. And let me say that the outcomes of this project will be available, are already available, and will be to the end of the project on the project's webpage. And I just have to thank here in the room to the colleagues and those that attended online for these rich and live discussions and participating here. Thank you. I don't know if you like to have some last words. We don't have any words anymore.
Thank you very much. Thank you for the project. Thank you for the audience, and thank you, Claro and Helder, for the project.
Yeah, big applause to everyone for the achievement, and let's hope this is not dying, but it's actually going to grow and flourish. Thank you very much.